Okay, we're going to start studying motion graphs. We're going to start with position versus time graphs and move on to velocity versus time graphs. So for a position time graph, I got time on this axis, I got position. Okay, and so whenever I see this straight line from A to B means it was going at constant speed. Okay, and the curvy line from B to C means it was changing speed. So for curved lines, we're going to say that it was changing speed. And for a straight line, it's going to be constant speed. Okay, if it's a flat line, it's at rest. Okay, you don't have to draw this, but let's say something started at position 2 and stayed at position 2, you would just get a flat line like that. Okay, the difference between the endpoints is the displacement. Okay, because displacement is change in position. Okay, and we'll do the math of that down here. And then the slope, this is x position, and this is time t. Okay. When we find the slope, we do change in y, so change in this, divided by change in x, change over here. And that would be delta x, for this one, delta x over delta t. So it turns out that that is the definition of average velocity. So we need to memorize how to be able to find displacement for one of these graphs, how to find average velocity, and to look at it and to tell whether or not it's speeding up, slowing down, and so on. So for the graph above, we look from A to B. There's a lot of things we can know about it. First off, it's moving in the negative x direction. You can tell that it has a negative slope. Okay, it's tilting down, just moving in the negative x direction. The next thing is I can say that it's constant speed. Why did I know it was constant speed? Because it's a straight line. Okay. Next thing I'm going to find is the displacement. To do that, I'm going to take final minus the initial. Okay, so at A to B, we ended at a position of -2, and we started at a position of 4. So it's going to be -2 meters was the final position, minus 4 meters was the initial position, which gives me -6 meters. So we went 6 meters in the negative x direction. We said that it was moving in the negative x direction up here. So it kind of confirms it. And then the last thing, the average velocity is going to be the slope. So change x over change t. So for this one, the change in x we just found up here was -6 meters. And the time it took was from 0 to, it looks like 9 seconds. So 9 minus 0 seconds. And that gives me -6 repeating meters per second. Negative meaning it's in the negative x direction. Now we're going to check from B to C. And do the same type of thing. So first, what direction is it going? Well, it's going from -2 to +4. So it's moving toward the positive number. So it's the positive direction. Okay, we can tell because it has a positive slope. Okay, or it's tilting upward. It is a changing speed because it's curved. Okay, and if it's changing speed, we want to be able to say if it's speeding up or slowing down. So this one is slowing down. And how did I know that? Well, we just said the slope is related to the speed, and you always read left to right. It starts out steep, it ends up kind of flat. Okay, so the slope is decreasing, so therefore it's slowing down. Okay, the slope decreases, the line gets flatter. that's how I'm going to tell if it's speeding up or slowing down. And then the displacement. Minus x initial. So it ended up at, looks like 3, and it started at -2. So I went from -2 to 3. So final was 3 minus -2, 2. And that gives me a displacement of plus 5 meters. So it's 5 meters in the positive direction. And then for the average velocity, delta x over delta t, it's going to be plus 5 meters. Now for the time, we don't want to just use the ending time here of 14. I'm going to do 14 minus 9 seconds. So that's going to be 1 meter per second. And it's positive because it was going in the positive direction.